Hey guys, how's it going? So last Wednesday, I took a math midterm and I said that I would get probably 14, 15. Turns out I actually got 19 out of 20. And it's really funny. Every time I think I do bad, I end up doing good. And every time I think I do good, I end up doing not so good. So let's take a look at the analysis of the midterm and its answers. So here we go. This is complex analysis. But this, my university calls it complex variables. So midterm one, I got 95%. The average is 65. The median was 13.5 out of 20 with a total of 75 students. I'm in the top 7 percentile. Don't mean to flex, but I just did. Oh, well. So question one. Show that f of z equals e to the power of z is entire, and show that f of z equals z conjugate is not analytic anywhere. So this is fairly straightforward. The average was 81% for this question. E to the power of z is e to the power of x times e to the power of iy. E to the power of iy is cos y plus i sine y. And you break it up into its real and imaginary components, u and v, respectively. And then the Cauchy-Riemann equations are u derivative x, u sub x equals v sub y, and u sub y equals negative v sub x. So the first thing you do is you see if these partial derivative conditions are equal, and you find out that they are. And not only that, a function being entire means that it is analytic or differentiable everywhere throughout the entire complex domain. And since the partial derivatives are continuous everywhere throughout the domain, the function is entire, e to the power of z. And then f of z is z conjugate, is x minus iy. U is just x and v is just negative y. So then u of x is 1, v of x is negative 1, obviously never equal anywhere, so it's nowhere analytic. It's important to remember that in the complex plane is different from the real plane, where a function, it's possible for a function to be nowhere analytic, yet have continuous partial derivatives everywhere. Yeah, so this question was pretty easy. If a student did bad, I would highly recommend him. No, if a student did bad on this question, I would highly recommend him or her to either drop the class or really start studying, because this was one of the most fundamental parts of complex variables. Question two, f of z equals z to the power of I. Absolute value of z is greater than 0, and then it's along the branch from negative pi over 2 to 3 pi over 2. And c is the path of the unit circle from 0 to pi. I'm not really sure why they put this negative pi over 2 to 3 pi over 2. It didn't really seem to have any sort of effect in my calculation whatsoever. I'm going to go to the second page first. So basically, z is e to the power of I theta. So z to the power of I is e to the power of I theta to the power of I squared is negative 1, so it's e to the power of negative theta. That's f of z of theta. And now the contour would simply be from 0 to 2 pi f of z of theta times z prime of theta. So z prime theta. Z is e to the power of I theta, so z prime theta is I theta. So then I wrote that here. So from pi 0 to pi, e to the negative theta, I theta, d theta. And then you differentiate it out. Yeah, not really much to say here. Yeah, and then that's how you do it. But I put this because I was told in class, the way my professor does it is anytime you have z to the power of c, you can say that z to the power of c is equal to e to the power of log, e to the power of c log z. Yeah, so then that's the way it is. So then z to the power of I is e to the power of I log z, and log z. So z is e to the power of I theta. So log of z is equal to the absolute value of z plus I theta. Wait. Yeah, ln absolute value of z plus I theta. Ln the absolute value of z is 1, so ln of 1 is nothing. Then it's I theta. Yeah. Question 3 is you have this function, and it says identify the singularities and briefly explain why the function is analytic except at those points. You don't need Cauchy-Riemann. Show on the circle that the c with the absolute value of z is equal to 3, and then you have the absolute value of f of z less than or equal to 1 over 40. Now, for this question, it's really you don't need Cauchy-Riemann. What you do here is you recognize a trick that anytime there's a rational function, it is analytic everywhere through the complex domain, except where the denominator is equal to 0. Why is that? Well, a rational function consists of polynomials on the numerator and polynomials on the denominator. And when anytime you and polynomials are entire. So anytime a function is addition, subtraction, multiplication, division with another entire function, the result is going to be entire, basically. And then here, so 1 is entire. The denominator has an entire polynomial. Polynomials are entire. So yeah. And it obviously can't be at where the denominator is 0, because 1 divided by 0, it's not continuous. And like you can use the contrapositive. So if a function is, if a function is differentiable, it's continuous. But if it's not continuous, it's definitely not differentiable. So the singularities are just those places where the denominator, it's 0 and you can't differentiate. So it's z4 minus 5z squared plus 4 is 0. Z is plus or minus 1, z is plus or minus 4. Yeah, and part B, this one, the average for question 2 was 76%. The average for question 3 was 60%. I could understand why people struggled. Question 3, use lemma. F of z is this. And then you break it down into z squared minus 1 and z squared minus 4, as indicated right here. By the triangle inequality, remember how the triangle inequality says that the absolute value of a plus b is less than or equal to the absolute value of a plus the absolute value of b? Well, the reverse triangle inequality is also true. So like the absolute value of a minus b is equal to is greater than or equal to the absolute value of a minus the absolute value of b. So the absolute value of z squared minus 1, you can, based on what I just said, is greater than or equal to the absolute value of z squared minus the absolute value of 1, which is just 1. And the absolute value of z is 3, so then that's 9 minus 1, which is 8. Z squared minus 4, the absolute value of z squared minus 4 is greater than or equal to the absolute value of z squared minus 4, which is 9 minus 4 equals 5. I'm just using the reverse triangle inequality here. The numerator 1 is always equal to 1. There's nothing interesting to say. The wood, the floor here is made of floor, right? Why? Yeah. And thus, so the absolute value of f of z in lemma is generally less than or equal to m. So then the absolute value of the f of z is less than or equal to 1 over 8 times 5, the numbers I got here, which is 1 over 40, which equals m. So you can say the absolute value of f of z is less than or equal to m, yeah, which is 1 over 40, and you are done. Take a look at the question if you like. Question 4, this is the one I kind of BS'd. I'm surprised I got 4 out of 5 on it. I thought I would get 3 or 2, but I'll take it. I'll take the free ride. So let z, we'll just do this one by one. I'll go back to it. So A, let z equals x plus iy and show that at the origin, f of z equals u of x, u plus iv, such that the way they did it here is, I'll just tell you what it means. U sub x at the origin equals v sub y at the origin, and u sub y at the origin is equal to negative v sub x at the origin. But somehow f prime 0 does not exist. What can you conclude about f? Well, there's usually two, without looking at the answers, there's usually two ways and two conditions you need for a function to be analytic or differentiable at a certain point. You need to, the partials need to satisfy the Cauchy-Riemann equations, but they also need to be continuous at that point too. So it's clear that the Cauchy-Riemann's equations are satisfied, but it must be that one or more of the partial derivatives are not continuous at the origin. Yeah. Thus, f prime 0 dne does not exist at the origin. Explain why curve C is a contour where z is 2e to the power of I theta from 0 to theta to pi over 2. This I just know what a contour is. This is a simple closed curve. Like, so basically the C is describing a circle that is centered at the origin with a radius of 2 from 0 to pi over 2. A quarter circle. It's a simple closed curve. It never intersects itself. X and Y are continuous from 0 to pi over 2. That's a necessary condition for a curve, for a contour. It's continuous. It's a simple arc since it never intersects itself. You can just say that it is a contour. Yeah. And part C, suppose f of z is analytic at z naught and let delta z equals delta x plus I delta y. Write and find the limit in terms of its components u and v that gives the derivative of f at z naught and when the approach of z naught is horizontal, that is if delta y equals 0. Honestly, I BS'd on this one. I completely didn't know how to do part C. Said f of z is analytic, so u of x equals vy, u of y equals negative vx. Limit exists at z naught because if f is differentiable, f is continuous. I just threw everything I knew to do part C. F prime z is, so I assumed like they were talking about the real parts. Like I saw this on a question somewhere. I don't know. It's the wrong limit. I lost a mark, but at the end of the day, I still got 19 out of 20, which is surprising, but happy achievement. Unlike the Darman kid, who his mom got him a tablet for straight A's, I got $120 from my parents. Not bad. All right, well, that's it for now. I've been pretty busy, but I think I'm going to manage some time on Thursday. I'm going to go over my Calculus 2 final exam. I'll definitely be teaching some more math now. Yeah. So that's all. I got to jump. I'll see you guys on the other side of the bridge. Catch you next time.